Hello everyone, welcome back to my channel. Thanks for watching all the previous videos and thank you for all the useful feedback. So today I'm going to solve JEE Mains 2019 from 9th April Shift 1, and here are the questions that we're going to solve today. So the first question that we are going to solve is from the chapter of functions. I also had one question from functions in the last video, and a lot of people told me that they want more examples, so I'm including this question. The second question that we are going to solve is from the chapter permutations and combinations. A lot of people have asked me why do I have permutations and combinations in each of my video, and a lot of people do struggle in this chapter. That's why I always make sure to have one example from this chapter. The third question today that we have is again from functions with some application of differentiability, which again I had like two questions in the last video and a lot of people found it to be really helpful. That's why I've included this example. The other one that we are going to do is from matrix. A lot of people have emailed me that they want some matrix and determinants as well. So I've included this example to see how people respond to it. And the last question that I'm going to solve today is from the chapter probability. Again, I have included a question of probability in each and every video. The same reason that a lot of people struggle in probability and they have reached out to me. So I'm including these examples. So let's begin. If fx is a non-zero polynomial of degree 4 having local extreme points at x equal to -1, x equals to 0 and 1, then the set S for x belonging to rational real numbers where f of x equals to f of 0 contains exactly. So here we are given a function and a set and we need to see what the set contains. So let's use the information given regarding the function and try to figure out what the function could look like. So we know that f prime of x is 0 for x equals to -1, 0 and 1. So we can devise what the derivative of f could be. It could be some constant lambda times x plus 1, the first root, times x minus 0, the second root, times x minus 1, the third root. And this thing is x plus 1, x minus 1 is x squared minus 1 times x, which is also lambda x cubed minus x. So this is what our derivative of the function should be. If we know the derivative, we can know what f of x is. We simply integrate the derivative, and the derivation of this is pretty straightforward. It is lambda times x to the 4 over 4 minus x squared over 2 plus the constant of integration c. Now we are given one information that f of x equals to f of 0. So our f of x equals to lambda times x to the 4 over 4 minus x squared over 2 plus c, and f of 0, plugging in the value of 0 instead of x, we just get c. And we know these two are equal, so we know lambda times x to the 4 over 4 minus x squared over 2 plus c is equal to c, which says that lambda times x to the 4 over 4 minus x to the 2 over 2 equals to 0. Now we know that lambda is a constant and that cannot be equal to 0. So we know that x to the 4 over 4 minus x squared over 2 is equal to 0. And this can be written as x squared times x squared minus 1 equals to 0. Sorry, x squared minus 2. So now the roots of this is x equals to 0 and plus minus under root 2. So the set S has these numbers minus root 2, 0 and root 2. These are the values of x belonging to real numbers where this condition f of x equals to f of 0 satisfy. So this means one of them is a rational number and the other two are irrational. And that is option 3, which is our answer. Two irrational numbers and one rational number. Let's move on to the next question. A committee of 11 members is to be formed from 8 males and 5 females. If m is the number of ways the committee is formed with at least 6 males and n is the number of ways that the committee is formed with at least 3 females, then, and we are given some options regarding the values of m and n. So we know we have 8 males, 5 females, and we know that the committee is to be formed from 11 members. So we know that the total members are 13 and we need to select 11 members out of it. So let's try to find what M should be. So M is where the committee has at least 6 males. So there are 3 possibilities. It is 6 males, or it has 7 males, or it has all 8 males. So the total number could be, so we need to select 8 males, 6 males out of 8 males. So that is 8C6. And the remaining 5 should be females. So we choose 5 females from the 5. Then add the second, that is we have 7 males. So we select 7 males from 8 males. So that is 8C7. Times we need to choose 4 females. So that is 5C4. Plus we have 8 males. So we select 8 males, which is 8C8, times the other 3 should be females. That is 5C3. Eight C6 is 28, 5C5 is 1, 8C7 is 8, 5C4 is 5, and 8C8 is 1, 5C3 is 10, so which is 28, plus 40, plus 10, which is 78. Now let's calculate N. We know that the committee should have at least 3 females. So we know that there could be 3 females, there could be 4 females, or there could be 5 females. 3 cases, and let's add the number of cases. So we need to select 3 females, so it's 5C3 times the remaining 8 should be males, so that is 8C8, plus we select 4 females, so that is 5C4 times the remaining 7 should be males, that is 8C7. Selecting 5 females, that is 5C5, and the remaining 6 should be males, so that is 8C6. And even without calculating the value n, we can see that this number over here and this number over here, these two are exactly same. So we know that m equals to n, which equals to 78, which is our answer, which should be option 2, m equals to n equals 78. Let's move on to the next question. Let f of x equals 15 minus absolute value of x minus 10, where x belongs to real numbers. Then the set of all values of x at which the function g of x equals to f of x is not differentiable is. So again, we know that this is from functions with an application in differentiability. I had a couple of examples in my last video, and a lot of people want more examples to be solved. So let's go step by step and understand how to solve this problem. So we know that f of x equals to 15 minus absolute value of x minus 10, where x belongs to real numbers. We know that g of x equals to f of x, and we need to find the points at which g of x is not differentiable. So let's try to find the function g of x. So that is f of x. So instead of f of x, let's plug in the value 15 minus absolute value of x minus 10. And now we need to find f of 15 minus absolute value of x minus 10. So wherever in the function f of x we see x, we replace it by this whole term. So 15 minus absolute value x minus 10. So instead of x, we plug in this whole value, 15 minus absolute value of x minus 10 minus 10. So it's 15 minus 5 minus absolute value of x minus 10. So this is our function g of x. And we need to find points at which this is not differentiable. So if we know one thing, that y equals to absolute value of x, this thing is not differentiable at x equals to 0, because the graph of this looks like this, and at x equals to 0 we have a king point, so we know this is not differentiable. So let's try to draw the graph of this one and see where it has king points and figure out all the points where this is not differentiable. So to start with, we can just play with some numbers, x equals to 5, 10 and 15, and see what the values are. So when we plug in x equals to 15, we would get 15 minus 5 minus 15 minus 10. We know 15 minus 10 would be 5. So 15 minus 5 minus 5, which is 15. So we know that there is a point which lies here, 15, 15. Then at x equals to 5, g of 5 would be 15 minus absolute value of 5 minus absolute value of 5 minus 10, which is 15 minus 5 minus 5, which is also 15. So we know that there will be some 0.5 comma 15. At g of 10, it should be 15 minus absolute value of 5 minus 10 minus 10. This thing is 10. So there would be some point over here, which is 10, 10. And one thing to note is that it is 15 minus some number. So, and the main thing over here is absolute value of x minus 10. So we know that any numbers greater than 10, we would have a positive slope. For any numbers less than 10, we have a negative slope. This is how we connect the graph, just by knowing that what slope it should be. And for any numbers greater than 15, we know this term will be greater than 5. So 5 minus that absolute term would be a number greater than 0, and 15 minus that would be negative. So we again know that this would go back down here. Similarly, for any values of x less than 5, it should again go back negative. And that is what the graph should look like. It is not drawn exactly to scale, it is just a rough representation. So we know that we have three king points, point A, point B, and point C. So we know that x equals to 5, 10, and 15. G of x is not differentiable, which is our answer, and it should be option 2. If the product of matrix 1, 1, 0, 1, 1, 2, 0, 1, 1, 3, 0, 1, so on until 1, n minus 1, 0, 1 is equal to 17801, then the inverse of the matrix 1 and 0 1 is. So let's try to generalize this whole product and see what we get. So multiplying the first two matrices, the product of which is 1 3 0 1, which is basically the next matrix. So the product of 1 3 0 1 with 1 3 0 1 gives 1 6 0 1. The product of this with the next matrix 1 4 0 1 is equal to 1 10 0 1. So one thing we can notice here is that these three numbers remain the same and this number changes, and this number basically is just the old number plus this number would give you this number. So basically we would just get this times this till n, 0 and 1. This should be the product of all these matrices, but we know that we only go till the matrix n minus 1. So here we would have this thing, and this matrix is equal to 17801, which means that the sum of these numbers is equal to 78, and the sum of the numbers till n minus 1 is n times n minus 1 over 2, which is n times n minus 2 over 2, which is 78. From this we know that n equals 13. So we need to find the inverse of 1, 13, 0, 1. The inverse of 2 by 2 is really easy. We switch these two diagonal numbers and put a negative in front of these two numbers. So the inverse is 1, negative 13, 0, 1, which is option 4. Let's move on to the next question. Four persons can hit a target correctly with probabilities 1/2, 1/3, 1/4, and 1/8 respectively. If all hit at the target independently, then the probability that the target would be hit is. So we know that the probability that person A hits is 1/2, probability that person B hits is 1/3, probability that person C hits is 1/4, and the probability that person D hits is 1/8. And they all hit independently, which means that the union of these events would be the product of these events independently, and we need to find the probability that the target is hit, which means this probability is 1 minus probability that there is no hit. So this term 1 minus probability of no hit is basically probability that there is at least one hit, at least two hits, at least three hits, or all four hits. And the probability that there is no hit is the product of the complement of the events, that none of them hit. We know that these are independent events, so we can just multiply their probabilities. So this is 1 minus 1/2, which is half. This is 1 minus 1/3, which is 2/3. This is 1 minus 1/4, which is 3/4. This is 1 minus 1/8, which is 7/8. And this difference comes up to be 25 over 32. So our answer is option 2, 25 over 32. Let's move on to the next question. Let the sum of first n terms of a non-constant arithmetic progression a1, a2, a3 be 50n plus n times n minus 7a over 2, where n is a constant. Let D be the common difference of this AP, then the ordered pair D A50 is equal to. So we are given an arithmetic progression A1, A2, and so on. And it says it is non-constant, which means we know that D is not equal to 0. And we know that the sum of the first n terms is 50n plus n times n minus 7 times a over 2, where a is some arbitrary constant. And we need to find this ordered pair. So we need to figure out what D should be, and we need to figure out the 50th term of this AP. So let's find just a normal nth term of this AP. We know one thing, that this should be Sn minus Sn minus 1. So if our arithmetic progression would be 1, 2, 3, 4, then we know that the sum of the four terms is 10. The sum of the first three terms is 6. And if we do sum of four terms minus sum of three terms, this is 4, which is basically the fourth term. So this is just a property of arithmetic progression. We can also do S of n plus 1 minus S of n. This would give you the T of n plus 1. It's the same thing. So here we know that S of n is 50n plus n times n minus 7 times a over 2 minus S of n minus 1, which is 50 times n minus 1 plus n minus 1 times n minus 1 minus 7 times a over 2. Solving this expression, we get 50n plus n squared minus 7n times a over 2 minus 50n plus 50 minus n minus 1 times n minus 8 times a over 2, which gives us, so plus 50 and minus 50 and go away, we are left with this term 50 plus n squared a minus 7na over 2 minus, this thing is n squared minus 9n plus 8 times a over 2, which gives us 50 plus n squared a minus 7na over 2 minus n squared plus 9n minus 8, all terms multiplied by a over 2. So we are left with 2na minus 8a over 2, and this thing would give us 50 plus na minus 4a. So we know that the nth term of this sequence should be 50 plus na minus 4a. We also know that the common difference is nth term minus the n minus 1th term, which is 50 plus na minus 4a minus 50 minus n minus 1a plus 4a, which is na minus na plus a, which is a. So we know that the common difference here is the constant term a. And the 50th term is 50 plus 50a minus 4a, which is 50 plus 46a. So the ordered pair DA50 is A50 plus 46a, which is option 4. So that's it from me today. Thank you very much for watching, and please comment with any suggestions you have or any questions or concepts that you want me to solve. Thank you very much.